So I'm here today to talk to you about making the value case for unit tests. I've got some feedback from my previous talk that I need to introduce myself, just to give myself a bit of an air of authority. So, hello, my name's Daniel. I'm the maintainer of the Imagic and Gmagic PHP extensions. I occasionally write RFCs for PHP, which is the way that people try and make it better. And if you want to check out any of the code I've written, particularly this library, it's impossible to pronounce, but it's really useful for writing unit tests. But more importantly than those things, I have a beard. And here we have a chart of beards. And as you can see, I'm right here at the top left. And you can't read the text, but it says, "Full beard or the philosopher, very trustworthy." So why am I here to talk to you about the value case rather than just talking about quality? The problem with talking about quality is that it's very hard to draw a direct line from increased quality to having a better business result. With value, you can make an argument that if we write more unit tests, we will save this amount of money on the development cost. And that's a lot easier to demonstrate than just talking about quality, which is always a little bit nebulous. So the first and most important thing to know about making the value case for unit tests is who you should be making the case to. Now, programmers aren't that persuadable a lot of the time. They're pretty set in their ways, and it's very hard to talk to them about value and say, if you did this, you'd be delivering more benefit to the business. So let's just skip over programmers. Salespeople. Typo. Okay. Salespeople, definitely not weasels. Salespeople have a very strong disincentive for you to write unit tests when you're writing code. Salespeople make a lot of their money by obviously selling products or selling services. If unit tests are included in the cost of a project, that puts the cost of the project up, or it can decrease the margin that the salesperson's going to have. So for a salesperson, for the salesperson themselves, it's a much better outcome for there not to be any unit tests to be written, and instead, or the product to be shipped to production and have all of the bugs be fixed there, because most of the time, the cost of fixing those bugs just gets ignored. Project managers. You would have expected project managers would be the people who you could persuade that that writing unit tests is a good thing. The problem is, project managers report to senior managers, and senior managements have an addiction to new features. They just love them. But also senior managers tend not to be the people who get woken up in the morning to fix bugs, not people who have to come in at weekends to work on projects to have their schedules slipping. So for senior managers, there's just no downside, or not that much downside, to having a lack of unit tests. And the issue is that project managers report to senior managers, and at the end of the year, when the project managers are having their pay review done, to a very large extent, that pay review is based off how happy they made the senior managers by delivering new features, not how efficiently the project was delivered during the year. So both project managers and senior management, it's pretty difficult to make the case for unit tests for. Financial directors, or the people who look after the money, are the only people who should, and actually have a legal requirement to, in a company, be looking to deliver the most value for the amount of money that is spent on the project. They're the people who you should be making the case for more unit tests to. Obviously, exactly how you do that depends on how big your company is, or whether it's the client that's wanting to have fewer unit tests delivered. But you need to, if you can, you need to get them involved and get them to see the value of unit tests. And then once you've done that, you can get them to start persuading everybody else that unit tests are needed. So how do unit tests provide value? We all know this. When you don't have enough tests, stuff breaks in production, and the client needs to find it. They have to report a bug. They have to stop what they were working on at the time. Frontline support has to analyze it. Second line support has to make sure it's a valid bug, make a reproduce case. then it's triaged to a developer. The developer has to analyse the bug, and then it's only at that point that the developer can actually start work on fixing a bug. With unit tests, you write some code, you run the unit tests, and 10 seconds later you can see that something broke. This is a huge difference. I'm sure everybody in this room knows that. I know it, but finance guys tend not to be part of the operations team, and so they don't know it. But even when something's known, if it's not tracked, it will just get ignored. What you should be doing is, at the end of each week, is producing a report to the finance team, or part of the project report for how the project's going. Of during this week, we spent 8 hours fixing bugs in production, which was time that was just not spent on actually useful stuff. If you don't track it, people just pretend that time doesn't cost anything, because if it's not tracked and not visible, it just doesn't exist to other people. But more subtly than this, time is not fungible, which is a funny word, which basically means that the cost of an hour of time is not constant. Imagine that your boss comes to you and gives you a task that's going to take about an hour to do, and says that they want you to do that task during the next week. Let's put that as the baseline cost of an hour. Imagine instead they come to you at 3 o'clock in the afternoon and want you to work on a task that's going to take an hour. In that scenario, you're going to be interrupting your work and having to work on something urgently without having to be able to think about it first of all. And so that having to work on stuff immediately has a slightly higher cost than working on stuff at some point in the next week. If your boss comes to you at 5:15 on Friday, you're definitely going to be aware that that's got a higher cost, both in terms of your own happiness, but also, let's face it, any code that you write past about 4:30 on a Friday, that's code that's going to need to be rewritten on Monday morning, pretty much. And so that having to rewrite that code shows that the task is going to take a lot more cost than just an hour. And for everybody else who gets called out, that's pretty much the next working day written off. Is anybody? I need to check the legislation what it says exactly now, but yeah, if you get woken up in the night, theoretically you're meant to have the next working day off. Anyone confirm that? Protected hours? No? Okay. So yeah, the value from unit tests comes from just saving time, but also just avoiding bad use of time. Tracking the exact cost of this is really difficult because an hour is an hour. So if you just write down, we spent an hour doing this, there's no indication of how much that cost, or whether it's actually an hour that's done a week planned in advance, or whether it was done as an interruption. The only advice I can really give you is that you ought to be tracking interruptions and how much of the time programmers get interrupted and get switched around from one task to another, because programmers only really work efficiently when they can plan their work ahead and just work as they go. If they're getting pulled left and right onto different tasks, it's really inefficient, and it can absolutely kills the productivity of a programmer. So, I've been using the word value a lot. I need to be more precise. Value is benefit minus cost. And a lot of the time when we talk about unit tests, people only hear about the cost. They hear programmers say, we're going to spend the next 2 weeks writing unit tests. When you're talking about unit tests to people who are not programmers, you want to drum up the benefit as much as possible, and just try and get them to focus on that, because otherwise all that they hear is the cost. They kind of don't see the benefit. But breaking it down even more, the benefit of unit tests is approximately equal to the probability that a unit test prevents a bug in production, multiplied by the cost of fixing the bug in production, and the cost is the cost of writing test and the cost of maintaining that test. Two different examples. A couple of months ago, I found myself trying to write a unit test to reach that goal of 100% coverage on my tests, where I had some code, and what it was doing was writing two files to a directory. And I wrote the first test, which covered the first file write failing within 5 minutes, but then I had spent about the next hour trying to figure out how to write another test where the first write succeeds and the second write fails. And I realised after spending about an hour on it that what's the chance of this ever actually happening? I mean, file writes happen. The first file write can fail if you just pass it a bad directory to write to, but then the second write can only fail when somebody unplugs the hard drive in the middle of the code, and if that happens, the code's going to be breaking anyway. So there's just very little benefit in trying to prevent the bug from happening. I mean, the hard drive's gone away. The server's just not going to work anymore. And then on the cost side, don't know how many people were here, but we had a talk back in August last year from Dave Marshall. He was talking about mockery to write unit tests with mock objects. And he gave an example where somebody had written a unit test that filled about 2 pages of screens. So that's bad to start with, because I'm pretty sure that unit test took at least 4 hours to write, if not more. But even worse than that, if any of the code that was involved in that unit test changed, that test would fail, just because all of the behavior of the mock objects would need to be updated. And so going forward, maintaining that unit test has a really high cost. So, as I said, this should be your guide when writing unit tests. Just writing tests that maximize benefit and don't cost too much. And if you do that, what should happen is this graph is, so along the bottom is the total number of tests written, and up the y-axis is the total value of delivered by tests. So it starts off that the first test you write should be the easy ones that cover a lot of useful code and are easy to write. And then as you go along, the tests get harder to write because you've picked up all the easy ones, and you just don't care as much about those bugs happening in production, just because either they're not that important services, or you've covered all the important stuff. And what happens as you keep writing tests is that curve goes negative. At about this point, that's a really bright light. At about that point over there, you're spending more time writing tests than it would actually save. Even if that bug occurred, it'd be quicker to let it happen in production and fix it in production, or do a release, rather than spending 3 or 4 hours to write a unit test to stop that from happening at all. So you can never know exactly where you are on this curve, but you should be able to have a clue approximately where you are. I think there's 3 zones. The first zone is down here, and you know you're here when everything's terrible, everything's on fire, and you do a deployment, and almost a lot of the time you have to do a second deployment straight afterwards, just because you've broken stuff. If you're in the zone, you should know that you can increase the number of unit tests you've written, and the value will go up. The second zone is everything feels okay. You can do deployments most of the time and nothing too major breaks, but you still check that the deployment's okay after it's done. And the third zone is, I call it the quality zone. It's when you've got huge amount of coverage on your tests and programmers are complaining that they're spending more time writing tests than actually writing code itself. As I said, the exact position on this graph doesn't matter. You just need to be able to understand where you are, and that will allow you to tell what would happen if you write a few more tests or a few fewer tests. So I said at the start that quality is a really hard thing to argue or make the case for. It definitely is important. The problem with, missing side. Okay. One of the things about unit tests is they deliver, wrong side again. So I've changed this slide about 3 times in the past 24 hours. I'll get there eventually. Quality is important, but it needs to be paid for outside of the development process. You can make the case that writing unit tests will save development costs. You can't always make the same case for quality, and in fact, you can make a pretty strong argument that if you want to have a very high quality application, it's going to cost a lot more than just the minimal viable product would be. You can read those words. Somebody needs to pay for quality, and it needs somebody who's willing to pay for it and make a business case for it. If you just leave it up to developers, they'll just do programming things, and it'll just, not be wasting everybody's time, but it'll be wasting money. Quality comes from spending money on UX research, iterating the UI to see if one works better, tweaking the sign-up process to see if that gets more users signing up. If at all possible, you need to get this paid out of the marketing budget. There's no point paying for a whole amount of advertising when you haven't done a whole lot of iteration on your product to make it better. And yeah, so just to summarize what I've said so far, you need to record costs and you need to set budgets. By which I mean, talk to the finance guy and say, we should be spending 20% of our time writing unit tests, and that will save this much development costs over the next 6 months. Finance guys can understand that, and once they understand it, they can help protect you from other forces in your company that are pushing continually for new features all the time. And once you've got a budget for unit tests, you can ring fence that or protect it, rather than having people come along and say, can't you just work on this new feature immediately? Time for a joke. So get ready to laugh. There's a tourist and he's lost in a rural island. He sees a farmer at the side of the road. He asks the farmer, excuse me, can you tell me how to get to Dublin? And the farmer replies, to get to Dublin, you don't want to start from here. It's not that funny a joke, but it is a very insightful observation that some journeys are much easier from starting from one location, than they are from another location. And exactly how you get to where you want to go depends on where you are. I love graphs. Here's another graph. Time, features delivered per week. Imagine we've got this team of perfect developers that write perfect unit tests, and they're writing unit tests as they go. And just week in, week out, they're just knocking out features. They never get a lag or backlog of unit tests that they've forgotten to write. They're just there writing tests as they go and delivering features. I was going to point out this feels really boring, or it probably would feel really boring. Just there's not that much excitement. You're just going in, doing your job. We've got another team that doesn't write enough unit tests. Instead, they just fix bugs as they go. So they've got hardly any code coverage on their tests, and they just fix bugs. They start off way more productive than the other team. But eventually their lack of tests catches up with them, and they get to a position where they're having to fix so many bugs in production, or stuff's breaking constantly, that they become way less productive, and so that they stabilize at a lower rate of features delivered per week. By the way, this line is here just a bit for arbitrary reasons. That line might need to be like way lower. just because some teams get very, very unproductive when they've got a huge backlog of tests. One of the key things you need to understand about unit tests is that they deliver their value over time. You write a unit test and it doesn't actually help straight away. It delivers its value 3 months later when you write some other code that breaks that unit test, and it's at that point that the unit test you wrote 3 months ago saves you, and that's when it delivers the value. Just to point out, TDD delivers tests straight away, so this talk's not about TDD. Feel free to do as much TDD as you want all the time. But time isn't fungible the other way as well. Sometimes an hour or a day now, it costs more than 3 hours or 3 days down the road. Imagine that you're working at a startup that makes some software as a service, and you guys think that you have a really good product, but you find it really difficult to attract customers. Your company is contacted by AWS, who tell you that they're going to be launching a new service in a few weeks' time, and that they like your product and they'd like you to do a demo for it at the AWS conference in London, and that they can offer you early access to that new service as long as you can write a demo and present that demo in 2 weeks' time. If that happens, having a demo done in 2 weeks' time is of absolute priority. Having unit tests that cover that demo is not a priority. If you write that code, make the demo, and then have to chuck all of that code away and rewrite it again from scratch, that's definitely the right choice to do. So some of the time, it's just to summarize what this says again, some of the time it's better to make short-term decisions that actually cost you more time in the long term, just to avoid a crunch point or to meet a deadline. These are business decisions. They have to be made by business people. I mean, we're techies. We can help business people make these decisions or make informed decisions, but techies aren't that good at actually making business decisions. So I've worked at some places where the techies make business decisions on behalf of other departments, and it's like, what are you doing? The exact way of developing this project should be entirely up to that other department, and not made by a techie person. And so just to show how that would feel like on this graph, with the team not writing unit tests, they could maybe reach all the features needed here. The team writing unit tests, it'd be further along. So yeah, as I said, sometimes it's right to do this, sometimes it's right to do this. It's a business decision exactly when it's right to do it. Okay. So imagine, for whatever reason you get to here, you've been writing code and you haven't been writing enough unit tests, and everything's horrible because you don't have enough tests. Trying to recover that situation is a very difficult thing. I should be trying to say what you should do here. I don't know exactly the best way. All I can say is what not to do. Don't do this. Don't decide, right, we're going to rewrite everything, or go through the whole code base and add unit tests to everything. And theoretically that would work eventually, but most businesses just will not survive. That if you're not delivering new features or new value to customers for an extended amount of time, your business is going to go bankrupt, or possibly you'll just be fired. Either way, it's not the right choice. What you need to do is try and be as efficient as possible when you're adding tests. So, for example, if you're working on an existing if you're trying to add a new feature to an existing module, write unit tests for just that module first and how it interacts with other modules, and just leave the other modules untested for the time being. Because otherwise you don't want to have your boss shouting at you, because he's going to have a good point that just writing unit tests doesn't fix productivity issues fast enough. But yeah, the exact path that you take is a pretty difficult one to work through. I'm getting near the end. So I want to say why I was talking about unit tests at all and not other things. Unit tests behave slightly differently to other things, in that unit tests, the amount of unit tests that you need varies depending on the number of programmers you need, because that's approximately how many lines of code are being written each day. Communication doesn't scale linearly. Communication scales as the square of the number of programmers in a team. We all like to think of communication as a good thing in general. It's not. Communication is terrible. When you have to have communication, I mean, let's face it, when you don't have unit tests and somebody breaks some code, they check it in, the next person who wants to does a checkout has to ask around the office, who broke this, what's changed, what do I need to do to fix my code to make it work with the new code, or when a deployment fails because somebody broke the build process, somebody has to go around and find out what needs to be done to fix it. There is good forms of communication, but that form of communication is bad. And unit tests are a really good way of stopping that required communication, allowing your programmers to not need to ask around the office of who broke what. And automation. The cost of automation goes down the larger your team is. If you want to set up Jenkins for some bit of software, it's going to take this amount of time if you're just working by yourself. If you're in a team of 10 people and the project's 10 times larger, setting up Jenkins costs this much time. So as a proportion of your team's development budget, all of the automation tools decreases in relative cost as the team size increases. This leads to a weird effect that unit tests are more effective for smaller teams to write, and for larger teams, doing things like integration testing or smoke testing are more effective ways of doing things. But also, just a lot of automation depends on the unit tests being there and being present, because if everything's automated but it's all breaking all the time, no one's going to be happy with that situation. So you need to write the unit tests first to allow the automation to take place. Now, I tried to end on a happy note, or an upbeat note. I failed. As a developer, you can make the case for unit tests and that the business should be writing more. I think you should be doing this not just in a whiny way, but actually if you're the company that you work for or the clients that you're working with doesn't do enough unit tests, you ought to maybe either sit down with them properly and do a little presentation of how they save money, or just make them do a budget and see that they would save money over time. But honestly, life is short, and a lot of people can't be persuaded. As a developer, it's your job to go to work and do what you're told a lot of the time. If you've made the case and the business has decided that we're not going to write unit tests, it's not your problem, and you ought to internalize that. Not just stop going to work, but go to work and say to your manager, when your manager asks you to come in at the weekend to fix some stuff that's broken, because just say, look, I've made the pitch for unit tests. If we had unit tests in place, this wouldn't have happened. It's your problem. It's the business's problem. Stop trying to make it my problem. And I believe all of our sponsors are hiring, so. Feedback there, please, if you don't mind. Slides will be there, and that's me. Oh, questions. Any questions? One at the back.
Why did you decide to decouple the discussion about unit tests from the DDD project?
So, a couple of reasons. This is where I'm going to use my time up. First of all, I am very bad at TDD, I have to say. I personally don't find it saves me that much time. other people do. I think that's mostly because I'm very bad at API design, and so what happens is I write my TDD tests, I get everything green, I go to use those that code that's covered by those TDD tests in production, and I realise that the API is absolutely horrible when you're actually using it. So that's why I've decoupled it in the first place. But the fundamental issue is that TDD is worth doing even in short time periods. Say that you've got a week to write some code, and you want at the end of the week to have a good working code. If you're good at TDD, you can spend the first day or half day or whatever time period thinking about the design of the code, writing the TDD tests, and using that to drive the design process. And writing the TDD tests delivers value within that week. It makes your code better before the end of the week is out. Unit tests, on the other hand, as I mentioned, you write a unit test and you feel good about yourself, but it's only months later when somebody else breaks your code and the unit test that you wrote picks that up. That's when most of the value is delivered from a unit test. So TDD delivers its value in a very short time period before code is written. Unit tests deliver their value over a long time after the code is written. Hello.
If like code coverage isn't the statistic that we should be going for, and like it's not what we should be focusing on, I'm interested in like what is your kind of what goes inside your head when you are looking at kind of the code that you're writing and prioritizing which section you should spend time on.
What goes on inside my head?
Yeah, dangerous question, I know.
What is this? Actually, I have a slide for this. Yes, I thought this was going to come up. I don't think, in general, having a coverage target is a good thing. In practice, it's often a useful thing. I think it depends entirely on what you're doing. I have code that has 0 unit tests. Basically, it's some code that generates some other code that calls the GitHub API, and I just could not think of a way of writing unit tests for that. Instead of what it does is an integration test. I mean, as I said, the code's interacting with GitHub, so it does the generation, then it runs some integration tests, calls GitHub, and that actually gives complete coverage of the code behavior. In general, if I was internal service layer code that's used inside an application, that's like accepting requests from outside and then passing on to another deeper layer inside the application. If I had to guess, I would say something like 90% to start with. And then once you get to that stage, figuring it out from there. What I'm starting to think more and more now is that once I've got to 90%, what I'm finding is that writing the remaining tests is really difficult, not because writing tests in general is difficult, but because the code sucks. For example, the example I talked about in the talk, where I had some code that's writing 2 files. What it was doing is writing one function block here, writing one file here, writing another file here. And because it was calling the file write functions directly, getting the coverage was really difficult. If I change that code to extract the file writing to another service or an external bit of class, I could just write that file writing service test once, and it would just not need to be tested at all inside the code that was calling it twice. So I'd say try and get to like a decent level, like 90%, but then once you reach that, you're probably going to find that there's better things to do than just try and push the coverage as much as possible. Any more? Nope. Cool. Cheers, guys.